All right, hopefully ggplot worked out well for you. So I'm just gonna go over my solution so you can compare and see some different options, try to explain what was done and why so you can understand it a little better. But keep in mind, if you're having a hard time with this, that's okay. We're here to help you. We just want you to learn. So if you have any questions or need a little bit more personalized support on this, send us an email. We want to help you. All right, let's get into it. So the first line here is our ggplot statement. And this is just going to tell us big picture of what information is going into this chart. So ggplot begins the function. It's going to create the chart. First, I need to say data equals chart info 1. So I'm telling it what data should we be using. And that's the object called chart info 1. And in that object, we had the number of COVID infections there were for every single day. So that's then the other information that it needs is this AES statement, AES for aesthetics. So what are the aesthetics going to be? Well, I want on the x-axis, I want the day it is, so the day of 2020. And on the y-axis, I want the number of COVID infections. So we'll just tell it x equals days, comma, y equals count. Give me the number of COVID infections for each and every day. Next line just says geom line. So this is real easy. I'm just going to say, I'd like a line chart. Could you just connect the dots for me? Tell me how many COVID infections there were for each and every day, but connect them with a line so I can see it visually. The next line here says geom point. You don't necessarily need this. I just like it. It's going to put a little circle for each and every data point, just so you can visually see how the days and the counts line up. I just like it. You can play around with that. The next section here is labs. So it's just labs is for labels. So this is going to allow us to personalize the chart. So within the lab statement, within the parentheses, we have x equals month. So label the x-axis to say month, because I want to know what month it is and how that relates to number of infections. And then y equals number of infections. That's going to tell us how many infections there were for each point in time. And this last entry here says title. So title equals COVID-19 infections during 2020. You can put whatever you want in here, but this will just give us some big picture sense of, what's going on in the chart. And so if we select all this and hit Control Enter, I'm just going to pull this up a little bit. Ta-da, now we've got a nice chart going on here. So we've got the months on the x-axis. We've got the y-axis with the number of infections. We've got a line with all of our little points on there. You can play around with these aesthetics all you like. You can always go to Google. You can watch the video from the module. Lots of different options. But this is like the nuts and bolts stuff to really show you what's happening. As we see, infections were really high. Then they seem to have dropped down quite a bit before a little bit of a resurgence. I can't help but wonder what political policies were going on. If, early on there might have been strict regulations on COVID behaviors that might have relaxed, resulting in a little bit of an uptick before it finally starts to drop down again. But that's the whole point, is we're trying to tell a story. We're trying to understand how are COVID infections changing over time. And so if we know what information we're looking for, then we can create the chart and try to fit that into our understanding of the story. The other chart that we wanted to make was looking at for 4 groups. So if we look at early in the pandemic versus late in the pandemic, and we looked at older people versus younger people, because we might think that early on, people weren't aware of COVID. So early on, you might see a lot of younger people and older people getting sick. But as time goes on, you might see that older people might intentionally start wearing their masks and, being sure to stay home because they're worried about COVID. So you might see that they have a decrease that's larger than the decrease was for younger people, because younger people, you have that sense of invincibility when you're young. So maybe that's relevant to the behaviors and the choices they're making, resulting in a different kind of spread. All that information is already loaded in this chart2 info object. So we've got the number of COVID infections for people who are older, the number of COVID infections for people who are younger. And we've also got information on whether or not it was early in the pandemic or late in the pandemic. And we might like to make a box and whisker plot, because in this case, we're not necessarily trying to compare the numbers one-to-one. We really just want to know overall between the two groups, how different were they? Was there a lot of overlap? How did the change over time go between the two groups? So like before, we're going to do start the chart with our ggplot statement. We'll tell it what data we're working with. So data equals chart2 info. And we'll need to pass it our aesthetics. So we're going to do AES aesthetics, and we're going to say X equals group period. So if you recall from the chart2 info object, that represents, was it older people statistics or younger people statistics? And was it in the early period or the late period? That's the goal. We'll have 4 groups here, 2 sets of statistics for 2 time periods, 4 different groups. On the y-axis, we'll have our count, so the number of infections for those different groups of people. And then I'm going to say fill equals group. So the fill statement it's just aesthetics, but it's very nice. I'm going to say, all right, I want you to color code the box plots. So that way the color codes correspond to if it's older people versus younger people. And so then we can say, okay, within the same group, is there a change from early to late for older people, change from earlier to late for younger people? Now that we've got that all set up, that's got to tell it what information to incorporate, but then we'll just need to give it a little more information on the specific details of the chart. So the next line says geom box plot. So that's saying, all right, I want box plots. You could leave it at that. I did this alpha equals 0.5 because I think that if you don't write this in here, it's going to make the fill-in color really saturated. And that's just a little bit intense for me. So I put alpha equals 0.5, so that just looks a little nicer. After that, we have this labs statement. So this is just labels. And so it's essentially the same as we had up above, but different labels this time. So for X equals, we say X equals group because we want to look at which group and time period it is. And then Y will have the number of infections. That's the same as we had before. But this time it'll be for the title is COVID-19 infections by age and time. Of course, that's the whole point. You can make these whatever you want, but this is just to show you some background on how to set up the technology. So if we select all this and hit run, or we hit Control Enter, we'll get our chart. And so here we see that early in the pandemic, there's a good number of infections for older people. Late in the pandemic, the box plot is like smushed. It's like way smaller. And, really, when we look at this box and whisker plot, the box tells us where the middle 50% of the data are, and the whiskers then just stretch out to show us where the variation in the data is. And so this is telling us that there's like minimal overlap in the late period for older people. In other words, once older people started hearing about COVID, they got a little bit worried and they were a little bit more careful. Compare now on the right side in these like bluer colors, we've got younger people early in the pandemic, and we do see a decrease for younger people later in the pandemic, but it's not as distinct. So the 2 boxes represent the 50% middle section of the data, and there's some distinct overlap between the boxes for younger people. Additionally, these whiskers have a good bit of overlap between them. So it's really saying that, yeah, younger people did show a decrease in COVID, but if we compare to the decrease we saw for older people, it's not nearly as large. And that's really important because that will shape our understanding of health behavior during a crisis. And that's why creating charts can be so helpful, because if you start from saying, well, what information will help us understand what's our research question, then we can create a chart that represents our research question. And then we can interpret the chart to say, does this look like what I thought I would see if my hypothesis is true? And in this case, yeah, it supports it. Older people drastically reduced in cases, probably because they're trying to be more careful about going out in public. Younger people showed a decrease, but it's not as big. And it's probably because some young people feel like they're going to be okay no matter what. And that's a part of why we need to provide clear guidance and on the importance of careful behaviors and how diseases spread and all that good stuff. All right, those are my solutions. Hopefully you got something kind of similar to this. As mentioned before, if you're having trouble, that's okay. But we just need to know. We need to help you. And so just send us an email, set up a meeting. We will meet you where you are and make sure you get where you need to go. All right, thanks so much, everyone.